So we're going to introduce me and Temporal, talk about order and chaos and what that means. Solution to the problem of order and chaos, durable execution. Most of the time will be spent in a demo, which has a button that says crash, which I love. It's also slightly scary. And then we'll recap stuff at the end. Introduction. So my name is Holland. I'm a technologist at Temporal. I previously worked at London Internet Exchange, Google and Clearbit, so various startups, big and small, and then massive enterprises. Google particularly interesting because their approach to failure changed my perception of everything. They expect failure all the time, they embrace it. They buy cheap hardware, they stuff it in data centers, and they expect stuff to fail, and they fix it at the software layer, which was kind of mind-blowing to me at the time. And then Clearbit, smaller startup. And Temporal is an open source durable execution platform, and we'll talk about what that means as we go through the presentation. It's already broadly adopted in the financial industry, and these are some of the people who are using it at the moment. I'm not going to talk about Temporal specifics today. As much as I can possibly avoid it, it's going to be about durable execution. And Temporal is an open source implementation. You can use it all for free of the durable execution platform. It has other features. I'm not going to get into those. We're going to talk about durable execution specifically. Order and chaos. This is an order workflow. I hope you can see. You can kind of see the comments, hopefully. So this is a very simple order workflow. We're going to use TypeScript for this just because it's the easiest to tie into demos. But we actually have SDKs for this stuff in all of these languages at the bottom. You can mix and match as you like. So we're going to talk about a simple kind of business use case. We're going to charge someone's card. We're going to reserve some stock for them. We're going to ship them something, and we're going to send a receipt. And this is the kind of thing that a CTO maybe who's knows enough to be dangerous in TypeScript might write, or you might just say, I have this amazing idea, and obviously this is quite unique here. No one's ever done this before. So they might have gone to ChatGPT and said, this is what I want to do, and this might be the code that comes out. I can't spend too long because we've only got 15 minutes. Normally I do audience participation. I want you to have a quick think about things that might go wrong, because this all looks like, oh, it's just that simple, right? It's just going to run through and everything's going to be fine. Obviously that's not the case. Reality bites. There's a lot of things that can go wrong, and this is just like off the top of my head, although this is my technology, I suppose, so they do come to me quickly. I want you to pay particular attention though to the stuff that's on the left versus the stuff that's sort of this side. Things on the left are actually kind of relevant to your business. If this is your business. If someone hasn't got enough money in their account, you don't really want to send them anything. Okay, that's kind of relevant. You want to change the control flow there. If you're out of stock, that's also a bit awkward, so don't try and ship it. But the stuff on the right is just noise. As a developer, you're not really interested in that kind of stuff. You're not going to take any different action. And if you imagine that you're the product owner describing this business use case, and you're talking to a developer, and they say, yeah, that all makes sense. But when we reserve the stock, if someone trips over the network cable, what should happen? And you're like, what? Right, it's jarring, right? It doesn't make any sense. We don't want to care about it as a developer. We want the code to be representing our business process as closely as possible. It's better for developers to write because they can get the ideas out of their head quicker. It's easier for people to read, developers and product owners. And there's kind of a lot more intuitive ability to add features and maintenance down the line. It's easier to onboard and so on and so forth. So just for lols, oh, why did that just slip to? No, chaos. Huh. I asked ChatGPT, because I'm very lazy, to try and take that code that I just showed you, and I'm not expecting to read this, don't worry, and add automatic retry handling around every step, at which point you could no longer see the business process at all because it's wrapped in retries and stuff. And it also has a naive but quite cute attempt to allow you so that if the process crashes halfway through, so say we get to step 4 or whatever this is, 3, and the process goes down, then this attempts to restart you back in the right place when it restarts. It requires databases and queues and stuff, and it's not a good time. So you can do this yourself, obviously. There are libraries that do retries and all that kind of good stuff in every language. Ideally, we wouldn't have to care about that. What is going on? Okay. Throughout my career, failure has been a common theme. That kind of came out wrong. One of the most reliable features of modern software is failure, right? You can guarantee, no one says, oh, our product has 100% uptime. No one. And the reason is everyone knows that stuff fails. Things are always going to fail. There's nothing you can do about it. You just have to accept it and do your best. And that's where reliability, redundancy, that kind of stuff come in. But you'll never see someone saying 100% uptime, right? We all know stuff fails. So this is the stuff we have to kind of care about that could happen in the real world. But what if we only cared about the stuff that we actually cared about? And the developers could write the code on, code like this, which represents the business process. And okay, the stuff on the left, we actually need to change the process because we don't want to ship people who haven't paid and that kind of stuff. But all these grayed out stuff, like developers don't care. And they can write code pretending that that never happens. That's the problem. This is the solution, durable execution. This is a great quote. Let's try that again. What appears there and what appears there are not the same thing. This is Tom Wheeler, a colleague of mine at Temporal. Failure is inevitable. We can't avoid it. Everything's going to fail at some point. But what if it's inconsequential? What if we can make it so that we don't care if there's a failure? We just carry on. And the product owner gets the business process that they want, and they don't care that someone tripped over a network cable. So this is kind of a visual representation. You're going to code above the line. All this stuff, durable execution is just going to handle for you, and you never have to see it unless you're interested. And you might be, and we'll get into that later. Right, demo. This is a demo which has a literal crash button in it, so it's actually terrifying. Can you see that? Okay. Let's bump this up a bit. Okay, so we're going to walk through some scenarios. This is literally running the code that I showed you at the start. This is in TypeScript, like I say, but you can do this in any language. It runs through Temporal, durable execution engine, but I have, with great pain, managed to turn off the durable execution for various aspects of this so that it will fail, and that's the whole point, right? We're going to see what happens and how far we can get without adding error handling code. So the code on the right, you'll see highlighted the line when it's running. I'm just going to run through this quickly. I'll skip through some stuff. So there's a happy button here that just skips the timeout. But by default, it's going to just run through this. So go through the process. There's enough money. We've got it in stock, blah, blah, blah. Transaction completed. One thing to note about transaction completed, you'll see that sometimes. What that means is that the business process has got to the end. It doesn't mean that the workflow has run the happy case necessarily, and I'll show you an example of that in a second. So now we hit reality. There's not enough money in the account. So let's run it again. You see the money thing here at the bottom. Okay, the charge is going to fail, right, because there's not enough money. But we've changed the code a bit. So this is business relevant failure. We want to know about this at the business level. So we've added try catch or like exception handling or whatever it will be in the language of your choice. And when the charge fails, in this case, because there's not enough money, we want to send an email to say, sorry, you didn't have enough money, we can't send it to you. So we've not carried on. So the transaction is completed. It's not happy exactly, but it's not sad because we didn't send something when someone hadn't paid. So we're still doing well. And this still represents the actual business process at this point. Now we get into the slightly more difficult stuff. So this is when reality really hits. We've got chaos. And what do I mean by that? It's any of the grey stuff that we didn't care about before, but the developer kind of has to care, normally, without durable execution. And the reason is that if I hit buy here, and then let's wait for the card to go through first, because that's more fun. But then I cause chaos, and that's network cable, that's database down, third-party API down, any of that kind of stuff. And it's a little monkey there. It's cute, isn't it? And we've lost the transaction at this point. I mean, you would never do this in production. It's badly organized if that can be the case. But in the pathological case, you start something because they clicked a button on a website and you're going through this ordering process and something went wrong and you're like, oh, done. So you've charged the card and now you've lost the transaction. It's never going to be shipped. Not a happy situation, sorry. So now we're going to turn the basic level of durable execution back on. It's the same code. Again, we've got enough money, so we're not going to fail it for the business reason. I'm going to press the monkey button again. Let's charge the card first. Okay, chaos. Oh, but it's carried on. So the first thing we get for free with durable execution is that it remembers how far it got through a process. Now this is just a network cable going wrong, so understand that this is a very small thing. The process is still running, but one network call you made failed. Temporal automatically retries that for you by default. It will do it exponentially. Sorry, it will do it infinitely with exponential backup. I keep saying those the wrong way around. So durable execution gives you the ability to pretend transient errors don't happen at this level. Reserve stock failed because of the network error. It will retry and it will carry on and everyone's happy. But it's still not that simple. So now I get a new button to play with, and this is the scary one for me. So we're going to run through the, no, actually I've skipped ahead a bit, slightly, sorry. So we've got a different case. Now I've shown you that we're going to automatically retry stuff if something goes wrong. And by go wrong, I said network failure or something like that. But what if the business use case happens now? So we've added code to automatically retry stuff, but we don't want it to retry if it's a business failure. And just to demonstrate that that does still work, you can tell Temporal, when an error comes back, this is not retryable, carry it on. And all durable execution frameworks will give you that situation. So you can promote an error from something that Temporal should just handle for you to something that the business process cares about. I just wanted to show you that that still works. Now we're on to the scary button. So if you get an error, you can do something about it normally, retry automatically or whatever, and handle it in some way. The worst kind of chaos is the kind of hardware chaos where the process dies in the middle. There's no error message. It's like kill -9 for those of you who are familiar with Unix. And so you've just like the ground has been taken away from under you, and you can't handle it in a meaningful way in the process because the process is gone. So now if we press the dangerous button, we're going to charge the card because, reasons. And now we crash. And the worker comes back up, it restarts, and immediately nothing happens. And because we've lost the transaction again, the process is gone. We can't do any retrying at that sort of line level because we've lost the state of it. Again, not something you'd normally see in production. You'd have some kind of log of the outstanding orders at least. So let's add that in. So we're going to crash it again, like that. Okay, so now we've got some kind of rudimentary wrapping around this that means that we know that something's gone a bit wrong. But this is naive, and we start the whole thing from the beginning. So we're not losing orders now, but we might charge your card 3 times before we ship, and that's also not a good time for obvious reasons. So we want to actually have the ability to know where in our code something fell off and come back automatically. And that is the sort of the final feature that durable execution will give you. So if let's try that again. Told you the break button was breaks in a sec. What is going on? Do apologise. Okay, if I kill the reserve stock, we've got some transactions that shouldn't be there at the top. I'm really sorry about that. I don't know why that's happening. It's mixing 2 workflow histories together, I think. So we can see that actually this time the reserve stock failed. I killed it with a process crash here. The worker restarted, automated Kubernetes, whatever you're using will bring the worker back up. And the reserve stock will carry on as if nothing had happened and the rest of it completes. So durable execution will give you the ability to sort of down to the item that you're in, the workflow level, business process level, automatically retry at the right point. This means that any work you've already done is not wasted. You're not charging the card multiple times, and you just get what you'd expect the business process to do for free without having to handle any of the transient errors. How are we doing for time? Okay, we're overrunning. So just very quickly, there's some unobvious stuff to this. That if you have an application bug in your code, an activity, or a third-party API is going a bit wrong and they've got a bug, the activity will just keep retrying in the background. So for example, if we're charging the card and we've got a bug in our charge code and it's returning an error, the process will just sit there retrying automatically for you. And when you deploy a fix, the next retry will go on to the new version and everything will just carry on as if it should have done, as if there was never any bug. So you don't lose any of the business process flows that were in place throughout all of that. It all just happens magically. And probably shouldn't go into that. Questions. I'm happy to talk about any or all of this, Temporal specific or otherwise at the booth, but just now, any questions on durable execution? Hey. Sorry, I'll just hand you the mic. Or I can repeat your question, I don't mind.
It's cool. Does Temporal handle any failure, or does it need to know the kind of failure, like whether it's a network or a hardware or a process failure?
So generally, I don't know outside of Temporal durable execution, but our model is auto handling. So we retry unless you tell us not to. So you only delimit or configure the cases where we shouldn't retry because they're very small. Like 99% of errors you don't care about. So that's where, for example, in the balance failure, we tell Temporal, if there's not insufficient funds, don't just keep retrying that, right? I mean, it might change, maybe, but it's unlikely. And so just give up and pass it on to the upper business process layer.
Because like if it takes a long time to fix your email server, you can say just stop retrying after a particular amount of time. Yeah.
Sure, yeah, any business process rules. So if an email is no longer worth sending, if you started trying to send it an hour ago, 2 days ago, whatever, you can tell Temporal, don't retry past this.
But will it remember it as well?
Say again?
Would it remember it as well?
Remember it, I don't know
Remember that like the email didn't get sent.
Yeah, so you'd see a failure. Again, I'm trying not to be temporal specific because I want to talk about job execution in general, but there will be a visibility thing which will show you what failed and when, and you can do with that what you will.
Yeah. Thanks. A very interesting presentation.
Cool. No, thank you. Anyone else? Questions, comments? What on earth were you just talking about for 15 minutes? Okay, thank you very much. Come and see us at the booth if you'd like.